Check in with your neighbor on these if you need to. Yes, guys, simplify if you can. I picked numbers intentionally to make you deal with some radicals. So. No, intentionally setting you up to think. On a Monday morning when it's cold out, you can do it.
Kind of a rough Monday.
Monday, full week. You can do it.
True. It's really true.
Are we ready, guys? Almost. Not at all. Uh-oh.
What's your quiz on this? Is it before or after break?
So usually it's its own thing where you have to just fill in the blank circle, which I'm still going to make you do. Grade-wise, I don't know how it's going to fit in. It may just be a thing that I just keep making you do until you get it right. So get it done and then you don't have to do it anymore. You're going to see today that, like, I'm going to teach it to you and you're going to do practice one right away and you'll be shocked at how much you know.
Say that.
I promise.
Okay.
All right, guys, let's look at these. So number one, what side did I give you? Long leg. So remember long leg, so 4 root 5 equals root 3 times the short leg. So I have to divide by root 3. So when you rationalize, did you guys get 4 root 15 over 3? For your x? Yeah, okay, ugly, but yes, that's your answer. It doesn't simplify. Then what do I do with that to get the hypotenuse? Yep, so 8 root 15 over 3. Okay, how'd we do on number one? Uh-oh, okay. Well, wait a second.
Collie. He gave us a movie to watch in a video guide, and I was like, what do you think I have to talk about?
You sure? Oh, for the second one,
I just wanted to make sure.
All right, guys, second one. What did I give you? Hypotenuse. The hypotenuse equals root 2 times either leg when it's a 45, 45, 90. So you can always remember if I'm going to the smaller side, I should be dividing. So I'm dividing everything by root 2. Don't rationalize here, just simplify this. You get 8 root 3 and you're done. Yay. Okay. I mean, you can. So if you have 8 root 6 over root 2, okay, so 4 root 12, but that's 4 times 3. Okay, to me, that way seemed easier.
So you can just simplify it there, right?
Always divide first if you can. Okay. Makes it smaller and easier to work with. You'll still get there the other way, but you'll be tired. All right. I gave you a hypotenuse in the third one. So we have to find the short leg first. What do I do to find the short leg?
What? Oh, divide by 2. Divide by 2.
So are we okay with x is 5 root 15 over 2? That's lovely. Okay. Then how do I go from short leg to long leg? Yeah, so I've got 5 root 15 times root 3 all over 2.
Yes.
5 root 45.
Yes.
Okay, but 45 is really 9 times 5, right? What's the square root of 9? 3. So this is 15 root 5 over 2. Yes? You got it? Okay. All right. One more thing with special right triangles, and this is actually the beginning of your notes here. The reason we review all of that is because that's where everything from your unit circle comes from. So, do you need me to go back, Ben, or are you good? So I'm just going to draw a couple triangles here. Sort of drawn okay. All right, guys, let's say I gave you these special right triangles, and in both of them I told you the hypotenuse was 1. Could you find the other sides? Okay, do that for me real quick. Maybe we can do that.
I used the circle before, and I solved this last time in real life.
Where it all comes from? That should have been like a happy sound and not like a sad groan. Oh, you doubt yourself a bit? Okay. No, it's all good.
One side just is. No, it's 45.
Oh, I heard.
Did you forget your contacts again?
Of course I did.
Okay. There's front row seats if you need them.
Oh, sorry.
You just want to squint and struggle?
I got it.
Okay. I can see it. It's a lot of stuff.
I got it. Yeah.
Oh, you know. What?
No. Front row's too much. All right, guys, are we okay with the 30, 60, 90? The sides being, short side being 1/2, long side being root 3 over 2. Good with that one? Okay. All right. What are both of the legs in your 45, 45, 90 triangle? So 1 over root 2, but we want to rationalize that to root 2 over 2. Okay, guys, those are pretty much all the numbers for side lengths you're going to need in the unit circle. You will see root 3 over 2, 1/2, and root 2 over 2 over and over and over and over. You'll get tired of them. Anybody questions on those or how we got to them? We're getting more comfortable with it.
For the second one, how do you get root 2 to do?
So remember, hypotenuse is equal to root 2 times the leg. So if I divide by root 2 and then rationalize, sorry, you get root 2.
Wait, yeah, no, I just bad addition.
It happened.
Oh.
Yeah, I was just showing how that rationalizes. Well, yeah, it's tricky. All right, let's try to actually make our unit circle. So guys, I'm going to use color coding when we do this, and I know I have the ability to draw a really nice circle up here. Make sure your circle is big on your paper. I'm going to give you, do you guys want a blank one? Would that help you? Okay, yeah. Give me a sec here. I know, you don't have that ability.
Are we drawing this one? Or?
Yeah, guys, you can have this, and then we're gonna do multiple things. Yeah, I would just fill it in on here, and we'll do some extra stuff back here.
Wait, is this our quiz last night?
It's literally all I remember.
Oh, okay.
The whole thing is the unit circle that you're right triangles or middles. And then all the other circle comments are on the outside.
I hate this.
Like all of these this is so sad.
That's what my cat teacher says. I don't understand. Jackson, sorry.
Oh dear. Okay, let me.
Very circular.
See, I just know that the unit circle is bad. The two opposite, that's much the same.
So guys, I will use several colors on here. I'll probably use red, blue, green, and purple. You need 4 different colors. So
Wait, where are we going to use images here?
yeah, you can do it on that. Yes, you're welcome.
Green, purple.
Yep. Well, you already have it on your. You can fill in the worksheet I just gave you, and so it's like already on there. Yeah.
Still, how many colors are 4?
4.
Make it work.
Let's do red. What colors are you using?
I'm using red, blue, green, and purple. Very nice.
I'll go get one myself. What color should I use to select?
I am using.
Right on the board.
Oh no, pick this one. You didn't tell me which color to use, so I picked it.
I said it like 4 times.
What?
It's too early for that.
It's okay. That's great. Whatever 4 colors you want, I will use red, blue, green, and purple. It's okay. All right, guys. We're going to start with some stuff that we know. This is considered 0 degrees, right? That's like our starting point. So if your angle went right through there, it would be 0 degrees.
Why is there so many like dashes? Yeah, like where's the like a color?
So yes, red is going to be like these quadrantal points for me, and then I'll switch.
Lines.
Yep.
Wait, where do we know? Where do we find?
The one with the degree on it.
Yeah.
Here, let me do this, guys. Hold on. I will pull up the exact same looking worksheet as what you guys have. And we'll go from there. So hold on. Let me open it.
Wait, what?
It's coming so that you know exactly where I want you to write it. Okay, the only thing that's bad about this is you can't see my whole thing all at once, but we'll get there.
Okay, we'll just have it twice.
Yes.
We'll have it twice.
All right, 0 degrees right here. Okay. What is over here on the left as far as degrees? 180. What is up at the top then? Okay. Bottom is 270. 360. Yeah, if we go all the way around. That's why you've got a couple of lines there on the right side. Okay. So far, so good, right? We're doing great, guys. Okay. What about this dot that I'm putting blue on there? It's halfway between 0 and 90. Okay, 45.
I don't know what.
I haven't used pi yet, no.
So not 135?
135 is accurate, guys. If you go to the second quadrant there, you can either think about adding 45 to 90, or it's halfway in between 90 and 180.
Is that the line for radians?
Yes, that other line is for radians.
229.
Okay. 225 down here. Again, you can just add 45 to 180. And then what do you think about the fourth quadrant? Goodness, yes, 315. All right. Let's do.
Wait, is it blue?
I mean, you do what you need to do.
Oh my god.
I don't think it matters too much. As long as you keep the color
It's all good. I'm just gonna leave it.
Just those 4 dots need to match whatever color you're doing. Everything about those 4
So they can't all match.
colors won't really be helpful then. All right, let's go here, guys. Now, let's think about it. Special right triangles, we had 45, 45, 90. The 45 has made an appearance. 30, yes. Okay. The 30, it is 30 degrees away from the x-axis. So this one over here, I will also put in green. It's going to be 30 degrees away from the x-axis. What will it be? 150.
Wait, that's 150.
Yes. Okay, then third quadrant. Again, 30 degrees past the x-axis there. What will it be? 210. And then in the fourth quadrant?
Same. It was 330.
330. All right, let's stop there for a second.
Yeah, colors match.
I need a greater circle.
No. Flip your paper. I know. Flip it.
All right, are we okay with those green ones that are all 30 degrees away from the x-axis? Okay, so what about that other one in the first quadrant? 60. Now, it is 60 degrees away from the x-axis every time. So what will it be in the second quadrant?
120.
120. What about the third quadrant?
240 is
240. Looks good. And then down there in the fourth quadrant, what will that one be? 300. Excellent. All right, so you could think your way through that from the special right triangles, right? The other way you can look at it is from the axis to a point is always 30 degrees, and then in between these will always be 15. So 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15. Like, so filling it in quickly, like working your way around, you can just count by 30s and 15s. But that's how the degree part works. Easy enough for the degrees? Okay. Let's try radians. Ariel, why is your laptop up there? Thank you. No, like, shut it. Yep, still not there. There we go. All right, guys. We're going to do the radians now. Okay? So I'm going back to the red dots. So I'm using red again. 0 degrees is 0 radians. Just put a 0 there.
in red.
Well, I'm using red, yes. I don't know what you are using.
I was like, I used the same color characters.
Okay.
We're back then.
All right. So, guys, 180 degrees. What is that in terms of radians? Pi. 1 pi, yes.
I think I should get like bait.
So 90 would be like pi over 2.
90 is going to be pi over 2, yes. Very good.
I mean, how does it work exactly with pi being so
So you can use that to figure out the fractions for all the others. So 90 is half of pi, or half of 180. So it's going to be pi over 2. 270, that's 1.5 times 180.
So 3.14 equals 180 degrees.
No, 3.14 radians is 180 degrees.
Oh.
Yeah? It's like inches and feet, remember? Okay. Pi radians is 180 degrees, yes. All right, guys. Pi over 2 was up at 90. Pi at 180. What is it going to be down at 270? 3 pi over 2, yes. Or 3 over 2 pi. We usually write it this way. 1.5 pi. Because what is 360 if I go all the way around? 2 pi. 2 pi. Okay? All right. I'm going to blue again next. Let's think about this. Yes, so 90 degrees was pi over 2, so 45 degrees is pi over 4. Now, we're not going to convert all of these the whole way through. That would be kind of a nightmare. You can count your way around the circle. So this first one is 1 pi over 4. The next over 4 here at 135 degrees would be essentially where it doesn't reduce. So 1 pi over 4, 2 pi over 4, that's 90 degrees, right? 3 pi over 4. That doesn't reduce, right? That's the next one that I need. This is 3 pi over 4. So I'm just counting through that numerator. 4 pi over 4, that's essentially pi, so I don't need that one. Yes, 225 is 5 pi over 4. And what is 315 going to be? 7 pi over 4. Okay, good. Let me stop there for a second. What you
No. No. Yes. Okay.
Are we there?
No.
Oh, I'll just think of it as awesome.
But now we're going to count with the 30-degree ones. I'll show you. Once we get to the end, you go, oh, okay. Perfect. All right, guys, let's look at the green ones next. So I'm starting with 30 degrees. What is 30 degrees in terms of radians? Pi over 6, yes. You can do the conversion if you need to, but it is pi over 6.
Pi over 3.
Nope, 30 degrees is pi over 6. Okay, so guys, the next one I'm going to is the next green one over there at 150 degrees. So same idea, I'm going to count through. So that was 1 pi over 6, 2 pi over 6, that reduces, so I don't want it. 3 pi, 4 pi, yes, 5 pi over 6 is the one I want. You count until it doesn't reduce. So we were at 1 pi over 6, right? 2 pi over 6, does that reduce? Okay, I don't want that one. 3 pi over 6, does that reduce? Of course it does. 4 pi over 6. Yay, okay, then I keep going. Do I want 6 pi over 6 for my next one? No, that would be a pi. Do you see I'm working my way around the circle? 7. Okay. Maybe.
Is there like a mathematical way of figuring this out?
Well, that's what I'm showing.
Find the pi over 180. No. Wait, isn't it divided by 180? No, it's the pi times the one. Yeah, pi over 180.
Yes. But guys, do not convert every single one of these. You will be very, very tired of converting. Yeah. So guys, 7 pi over 6, I got to get all the way to the 330 degrees now. What is that one going to be? Yes. You're getting it. We're going to do it again with the purple one. Yeah, but not if I give you a timed one of these and you only have a certain amount of time to fill it in. No. All right, so 60 degrees, that's what we have left. What is that in terms of radians?
2.
Pi over 3, not 2. It is pi over 3.
3, yeah.
Correct. 2 pi over 3 is the next one.
Slender.
Good. All right, third quadrant, what do you think? 4 pi over 3. And then...
Wait, so this isn't the same rule where the is on the only simplified?
No, it absolutely is the same rule. So we had 1 pi over 3,
Yeah.
2 pi over 3,
Yeah.
3 pi over 3 reduces, so I don't want it. So the next one's 4 pi over 3, and 5 pi over 3.
Yeah.
Okay.
Wait, could you go
Up. Yes. Okay. Now we have to do ordered pairs for each one. So I'm going back to the red again. Ordered pairs. All right, it is the unit circle, meaning the radius is 1 unit long. Okay, so over there is 0 degrees. What would the ordered pair be? 1, 0. What will it be up at 90? 0, 1. What about 180? Okay, and down at the bottom? Yeah. It's actually very simple, that part of it. Right?
That's the easiest twist.
That is the easiest.
It just goes downhill from here.
It's very patterned. You'll like. We're gonna do these three, and everything else is just the signs, positive and negative. So it's just those things. Roses are fun. All right, guys, we're doing the blue, the pi over 4 next. So let's think back to, oh, and I didn't have it on this one. When you had your 45, 45, 90, okay? I'm going to draw in a triangle that's not going to stay, so you guys don't need to draw this. What we're looking at is this triangle right here, okay? With a hypotenuse of 1. This is your x side, this is your y side. How long are they? As my triangle disappears. Because it's the magic pen. So each of those are root 2 over 2. So the ordered pair here is root 2 over 2, root 2 over 2. It's a 45, 45, 90 triangle with a hypotenuse of 1. Look in your notes. 45, 45. Yes. Yes. We'll be using the 30, 60, 90 for the other two. Okay. You have to start thinking of it in terms of x is the horizontal piece and y is the vertical piece, just like you would graph. So all the other blue dots, you know the ordered pairs to them. What's the only thing that's going to be different in the second quadrant? Yeah, so the x will be negative over here, so negative root 2 over 2, root 2 over 2. What about in the third quadrant? Both negative. And then in the fourth quadrant?
Negative y.
Yes.
No.
So if you know the first quadrant one, you know all of them. Okay. All right, we'll do green next. I'll draw it in so it stays here for a minute. So guys, this is the little right triangle that I'm now thinking about. Hypotenuse of 1. This is your x side, this is your y side. So which one is the short leg? The y, and then the x is the long leg, right? So what is the ordered pair going to be for this point? Root 3 over 2, 1/2, yeah.
How do we know that 30 degrees is like right there?
Because that's what we were talking about when we labeled it as 30 degrees. We're 30 degrees away from the x-axis. We're always talking about the central angle when we do that.
That's the kind of angle of 30 degrees.
Yep.
Okay.
Okay, I'm going to get rid of my triangle here. I'll label that. Yeah.
How do you know that x is horizontal? Oh, we just x.
X is horizontal, y is vertical. Yep. All right, so can you label all of the green points now? Yes. Negative root 3 over 2, 1/2. Guys, just one dot left here. Purple left to figure out. So again, I'm going to draw this and then make it go away. This is now the triangle we're looking at. So now we're talking about this 60-degree angle in here. Do you see how the x is now the short leg and the y is now the long leg? So what's going to happen with my ordered pair? Yeah, it's just going to be 1/2 root 3 over 2. And that is your whole unit circle. Yay! It is so much simpler. You guys will, yes. You guys will be much more comfortable with radians in a very short amount of time. I know you're not yet, but you'll get there. Okay, guys, flip over the circle I gave you. Can you see what you wrote through it or not? No? Okay, so let's practice.
Oh, yeah, I guess.
No, you know it now. Yes.
Yes.
I'm going to put a timer up here, so hold on.
Oh,
Wait.
why would you just
Practice. Let's see how much you know.
5 minutes?
5 minutes, guys.
I think I need like 5 minutes.
Ready, go.
What? Okay, yeah.
No cheating, because there's no point. It's for you. I mean, there's never a point to cheat, but... Ready, go. Okay.
Oh, I don't lose colors.
It's up to you. If they help you, go for it. Okay, guys, that's 5 minutes. All right, I'll put the other one back up here. You can check. How'd we do? Do you know more of it than you thought you probably would? Like, you can see the patterns, and it's almost like a rhythm to it, right? Like, there's aspects of it. So, guys, keep practicing this. You will have, like, timed assessments on this to make sure you know it. Haven't decided yet how that's going to fit into the skills-based grading, but you will absolutely see this in a, I will hand you one and you'll have 5 minutes to fill it out kind of thing, okay? So just practice it. The better you know your circle, the easier everything else we do in trig will be for you. If you struggle with this and have to think through it and it's hard for you all year, everything else is just that much harder. When we get to graphing polars, and I'm like, okay, well, what was the cosine of 3 pi over 4? And you're like, I don't know my circle, let me think. Like, nope, it's got to just be automatic, okay? So learn it, practice it. It's like a quiz that I give you the answer key to, right? Yes, and I will post a blank copy of this on Schoology for you as well, so you can print them, but I'll give you another copy before you go today too, okay?
When's the quiz?
Probably next class, but we'll probably do it more than once, is my guess. I don't know. We're sorting that out. Just be ready.
Just every topic on this.
Yeah, just before you go to bed, do a unit circle.
Right when you wake up,
Sleep with it under your pillow, you know. Perfect. The trig fairy will visit you. Yes. I like it. Anybody questions on any part of it? We okay with that? Sure. Which part is that? What you need? It doesn't all fit. I'll post the filled in one on Schoology too. So, I mean, I know you have it in your notes, hopefully. But. No. I think it's interesting the way it's all connected.
So, like, I understand that I get everything after quadrant 1, but how do you get, like, the everything? Or do you just don't know?
So the ordered pairs, the radians, or both? Okay, so the radians, you know, like 180 is pi, right?
Yeah.
So I just think fractionally through it. Like I know 90 degrees then is half of that, so pi over 2. I know 45 degrees is half of that, so that's going to be pi over 4. And then if you need to, like 30 degrees into 180, that's a sixth of it, so that's why it's pi over 6. And 60 degrees is 1/3 of 180, so that's why it's pi over 3.
I think I get it.
And then the ordered pair part, just draw the little special right triangle. Like, you know, whoa, maybe.
Oh, like making the hypotenuse 1.
Yeah, and I shouldn't draw it that direction. I should draw it the other way for you. Like, hypotenuse of 1, short side going to be a half, long side. So, like, this is your ordered pair. Or do the 60. Yeah, okay. Yeah.
The long side be the other side, because like if you're doing like
Wouldn't it be 1 what?
like to the right of the circle, like if you were to flip the like you scroll down, you see where it says the coordinate 1, 0. So wouldn't that that side right there is 1?
Yes, this is a length of 1 right here, because that's the radius. So that's how we get to the 1, 0.
Oh, same. I was just like.
You can't really draw a triangle for the ones that are on the axis. All right, guys, so now let's look at how we're going to actually use this. Okay, so little refresher here.
Is this back to like our piece of paper now?
Yes, back to your piece of paper. Yeah, I'm drawing like a little weird circle thing here. I would draw the circle. And maybe I should have made it bigger for you. That is a theta right in there. Let me draw it a little bigger because. Oh, yeah. We are going to use lots of Greek letters when we do trig. Theta is the one we use the most.
Wait, is that like a 45?
Not necessarily, just any angle in there. It is theta. I'm always Theta. Theta.
Let's do the most ugly symbol.
Okay. Oh yeah, I'm writing that as if you can see it, Adam. So. Does it make sense to you the way I labeled the sides X and Y? X being the horizontal piece, Y being the vertical piece. What do you think R stands for? It's the radius. That's the hypotenuse of my triangle, but isn't it also the radius of my circle? Yes. Okay.
Is the theta for the
That aren't what? I'm sorry. So we will, but that'll be like a whole separate thing we talk about. Yeah. What we're doing today will all be something that you learned on your circle today. All right, today. Enjoy today. So let's set up the ratios that hopefully you remember from geometry. So if I'm talking about sine of something, do you guys remember SOHCAHTOA? Okay. Opposite over hypotenuse. So if I'm looking at the theta there, what is sine of that theta? Y over R, good. Let's do cosine of theta. Yep, adjacent over hypotenuse, so that's going to be X over R. I heard it back there. Tangent is going to be Y over X. And guys, again, every time the angle we're talking about will be that central angle, that angle right in there by the origin. It's never going to be the angle out on the circle, okay? It's always in the center. Now, do you guys know cosecant, secant, and cotangent? I go, what? Okay. So cosecant, we abbreviate CSC. It is just the reciprocal of sine. So what will it be? R over Y, yes. Then we have secant. What do you think that's the reciprocal of? Yep, and we abbreviate that SEC. So that one's R over X. Cotangent. Yep. Cot is X over Y. Excuse me, guys. All right, specific to the unit circle. Sorry, guys.
has keyboard, desks, and a chair.
No, I'm on that. That's what you're in fact, it'll probably end up being that's my future career path.
Okay, I think I'm better. We'll see. Let's see if it lasts. Guys, in the unit circle, what does R equal? It's the radius. How long is the radius in the unit circle? 1. So, no, just these two. So guys, what will sine of theta equal if we're in the unit circle? Okay, we know sine is y over r, right?
Yes.
Just y, yes. And what will cosine of theta equal? Okay. Now, again, guys, that is specific to the unit circle. If we move outside of the unit circle, then you have to go back to these. Okay. So, let's try some. Guys, you can have your unit circle next to you while we try these. Nope. Goodness, I'm dying today. It's like the coughing starts and I can't make it stop.
Doesn't stop, yeah.
I was dying. I was literally like dead.
That's not good.
I saw the light.
All right, guys, let's do this one together. The sine of 3 pi over 2. All right, I'm talking about sine. Is that x or y that I'm looking at? Y. Okay, so on your circle, find 3 pi over 2. Down at the bottom, right? What is the y part of that coordinate? Okay.
Oh, I see.
Yes.
The side actually.
What is that number?
Oh.
Wait,
I
what?
always forget like what sinus or cosine.
We know. So she said look for the y.
So that's the theta. That's the angle we're talking about.
That's the funny letters.
Because what we're writing up here, like sine of theta equals y, cosine theta equals x, that's like, yeah, whatever angle we're talking about.
So if it's cosine, is it for the x value?
Yes.
Is there a way to remember that sine is y and cosine is x?
Siney? I don't know. Yeah, you just know.
So what about for cosine?
Is it only, there's no text for this?
We will do tangent, but that's still going to be y
But
over
the
x.
y is sine. Oh, what'd you say?
Jane?
Can you just write sine of 270 is also cosine?
Don't change it to degrees. You're going to get to a point where you're more comfortable with the radians anyway, but I promise. Yeah. Yeah, so since it's sine, I know I'm looking for the y value, okay, because sine is y, cosine's x. And then you go on your unit circle to where 3 pi over 2 is, and it's the y value in that coordinate. Okay, let's do another one. You guys will catch on, I promise. We'll start easy here. All right, cosine of 5 pi over 4. A minute. What is r in the unit circle? Yeah, there you go.
Where's 5 pi over 4?
Was it negative?
Negative root 2 over
2, yeah.
2.
Yeah. Do you guys see how knowing the circle is going to be pretty important for doing this? Yeah. Okay. All right, let's do a couple more easy ones and then we'll add a little bit more. Let's go back. Let's do maybe sine of 5 pi over 6.
Why?
That teacher actually.
Okay. Why is the signing thing actually sticking in my head?
It does, I know. It's the weirdest thing. Signing, I know.
Because I was like, I started laughing at it.
No, but it's the weirdest thing that sticks, so
I don't like this.
whatever works.
Wait, 5 pi over 6.
Hey, Mr. Light, how are we supposed to
So
do
it's
this?
an A.
So, like, it should become tattooed on your brain. Like, you close your eyes and you just see the circle. That's why we practice it so much, so this becomes quickly.
That's how it should be.
Yeah, it's both. And you'll get to a point, like, you're stealing my color.
I'm asking for consent to steal your.
Why? I'm asking to steal. You may borrow my pink pencil. So it's kind of a combo of like, you just get comfortable with, you know where the over 6s are, you know where the over 4s are, where the over 3s are, you know, so you start to just visualize it better. Right? Like all of the blue ones were the over 4s, right? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. I think I did green for the over 6s, 1 over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, and then over 3s were purple, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Like, you get just very comfortable with those. It takes time. You're not yet at all. You're very uncomfortable with them right now. That's okay. Yeah, I mean, you need it, but you're going to use the radians more than the degrees.
Are you also going to ask us the inverse as well as some of the...
Oh, that's long away.
But this year.
You'll be much more comfortable with it right now. All right, guys, what'd you get for sine of 5 pi over 6? 1/2, yes. Are we okay with 3? All right, let's try another one. Yep, you just find the y. Let's do cosine of... We'll do 11 pi over 6.
I got it.
It's okay. I know you need to look at it right now.
It is 11 pi root 3 over 2. Yeah, it's like. Wait, is that a 2? Yeah, 12 sides. So you see where it is as closest to? Wait,
We'll do tangent next, guys. And then we'll do cosecant, secant, cotangent, all that good stuff.
Oh my god, I can't.
All right, let's add a little here. How about tangent of 3 pi over 4? You have to think a little more when we get beyond just sine and cosine, because it's not just the x value or just the y value.
both.
It is. It is.
It's not the y over the x?
It is y over x, yes.
So y over 4. Where is that? Oh. Yeah. Over root 2 over 2. No, it's root 2 over 2.
Oh no, I negative. Y over x, you said?
Negative.
Wait a minute. Oh, I see how it's so bad. Okay, I can see how this is easy.
You see it now? Yeah, and like we just use it so much that...
I see what's happening.
Now guys, you're not ready for any shortcuts yet with tangent because you just started it, but you will get to a point where you also can just look at it and go, oh, I know what the tangent of that is.
What?
I know, it's crazy. We're not there yet. Like, you still, right now, you need to write out, like, what is y over x and simplify the fraction. You'll start to see, I get the same answer every time at this point and at this point. Like, you'll start to see the connection. There's only so many answers you're going to get. Like 3 tangent answers.
I hope so.
Ben? Yep. I mean, you can do the work of like multiplying by the reciprocal and all, but
I got it.
yeah, yeah. Do it the shorter way. Let's do another tangent. How about tangent of 2 pi over 3? I don't know why I'm hanging out in the second quadrant for you, but I am.
Is it y over x?
Y over x.
Is this less complicated?
Probably nowhere near as bad as you created it. Yeah.
That's fine.
Yeah, because then you simplify it.
And then
No.
He's happy.
Oh, yeah.
Yeah, the huge case I will be one over. Yeah.
Haven't asked you any secant, cosecants, or cotangents yet.
Yeah. That's why it's going to be this.
Oh, that makes my points. Yeah, that makes my points.
Did you get negative root 3? Yeah?
No, I mixed up the. I thought it was 6.
Wait, yeah. Really important. Oh, cosecant? What?
Cosecant 7 pi over 6. Do you want help?
No, we don't need
No,
help.
no, no.
We don't
Okay.
need help at all, facility.
All right.
Oh, wait. It's just 1 pi over 6. 1 over 7 pi over 6. Oh, I guess I'm
Okay. Yeah. So you're just into the third quadrant. Okay. You're like, great. Now what?
So that 1/2 over 3
Did you just like speak?
Normally,
7 pi over 6.
Wait, is it just 1 over 1 over? Is it just negative?
I will let you guys get there, and then I'll show you probably an easier way than what you were trying to do.
It's r over y. And if r is y, then it's just a 1 over negative 1/2. Right?
All right, guys, let's look at it. I would think through this. Guys, you know cosecant's related to sine, right? So what if I had asked you sine of 7 pi over 6? What would you tell me?
Okay. Oh.
Negative 1/2, right?
I didn't think of that.
Okay. Cosecant is the reciprocal of that. You don't have to do 1 over 1 over. Like, just flip it. It's negative 2 is your answer.
So wait, I was still right though, right?
You got to negative 2?
Yeah, wait, but you're not supposed to do 1 over.
You can. It's just
But it
still.
works, right?
Yes, it's just a little longer. So guys, if it's cosecant or secant, Just find the sine or cosine and then flip it. You may have to rationalize, and again, you'll get very comfortable because you're rationalizing the same thing over and over and over. All right, let's try another one. Let's try secant. I'm going to throw a little twist at you.
No, you're good. Okay.
I don't like I like linear plots.
Well, slight twist.
I'm on board. I'm on board.
Okay.
I'm on board.
Because you can do it.
Yes, we can. Yes, baby, we can.
That's perfect. It's going to be an interesting recording today.
Minus 45.
Or the same as 7 pi over 4. Like you're just this far into the fourth block.
I have one photo friend.
It is the secant of 7 pi over 4. So find the cosine there and then flip it. The angle you are looking at, negative pi over 4, is the same as 7 pi over 4. Yes. The answer to this problem is not 7 pi over 4. Okay.
Yeah, but it's the same, right?
Yeah.
But you use like the 7.
Yeah.
Cool, got that part.
Co-terminal angles.
It's so funny, I couldn't remember what that word meant. I just knew like how to do it.
Yeah.
I was on the mathematics and I was just like, what is that word?
Very fancy word.
Is it just like
1 divided.
Mm-hmm.
oh my god. I'm gonna really not do it. Yeah, great.
Yeah.
What's the way to mom boy?
Are you getting just root 2?
Yes.
Okay, are you getting 2 root 2 over 2 and forgetting to reduce?
I got 2 ways to say how do you do it? Oh, indeed.
You're at the wrong point. So negative pi over 4, that's here. Your ordered pair would be root 2 over 2, negative root 2 over 2. Secant is related to cosine, so I'm looking at the x. I flipped that. Rationalize. Reduce.
Wait, it's not root 2?
It is root 2. No.
I knew it then.
Nope. Don't change the sign. You just take whatever it is and flip. Why what? So negative pi over 4 means go backwards pi over 4. So however far pi over 4 is this way, you go back that far. Yeah. Yes, exactly. You've got it. Yeah. 1 over root 2 over 2. Sure. And then rationalize. Yep, same thing.
Oh.
There's a lot of ways you can get there. All right, let's do one more. I don't think we've done a cotangent one yet. So tangent was y over x. What is cotangent? X over y. Let's do cotangent of pi. Ben?
Going back to the it's just pi? Nice.
Yep. And then when you flip and multiply and rationalize, you would get to root 2 eventually. That's what I was doing in the purple there. You see it?
It's gone. Dead.
It's a hole on the
Off
ground.
the earth.
Oh my god.
That's not exhausting.
The holes are back.
It's undefined.
No, and only impossible.
Don't tell me no solution. Don't tell me does not exist. Tell me undefined, okay?
But it's not undefined.
Why?
I said tell me undefined.
So all I heard was don't tell me and then undefined.
Wait, why?
And there's seven.
Why what?
Why is
Zero.
So if you do cotangents x over y, right?
it right?
Your ordered pair at
Yeah,
180.
no, but like on the. I understand that. But why like on?
Okay, so when we get to graphing cotangent at pi, you have an asymptote.
Oh. I see. It's under the asymptote.
Yes, exactly.
Okay, that's what I was wondering.
When we
I was
get to
like,
graphing, we're going to unwrap the unit circle. I'll be like, remember these points, and then you turn it into a graph. It's kind of interesting.
So I was like, that makes sense on paper, but then like why?
Why? Yeah.
I guess. That's how I got it.
Yeah. You're good.
Who's drawing? And
All right, guys. Oh, so Rebecca was asking, why is it undefined there? When we get to actually graphing the trig functions, anywhere on the circle that it's undefined creates an asymptote in your graph. So that's not today. That's much later in the skill. It is in skill 5, though. So.
Oh, lovely.
Yeah. Yes.
It's later this month.
I know. It is later this month. It is like, yeah, it's right after Thanksgiving, guys.
Oh,
You will be very thankful for that.
I'm gonna forget everything over and over. Like I'm gonna do absolutely.
It's okay. You don't have to do anything over Thanksgiving.
I wish she was doing that. That's when that starts up.
All right, guys. I am posting your math space right now. That is the end of your notes. Yes, I will. And guys, if anybody wants an extra blank circle, pass those out for me. Thanks.
I can't take this. I appreciate the sharing.
Oh, okay.
You get a test back to that?
Yes, kind of, maybe. You know what? Actually, no. Miss Rowland has someone taking it. Let's do it Wednesday in class, okay? I know. I also haven't put stickers on them yet, so I need to do that for you. You need, like, I have some very fun turkey stickers for you.
I'm never taking my test unless I get it.
You just refuse.
It's gonna be a long day. I can't move during oral.
I know.